Hello and welcome to another complete Edexcel GCSE PE lesson, where you'll learn absolutely everything you need to know on topic 3.4, the long-term effects of exercise. Before we begin, a quick reminder that Edexcel GCSE PE, the complete course, which includes a dedicated section on component 4, the personal exercise program, is now available to download, link below. So you need to describe the long-term effects of aerobic and anaerobic training and the benefits to the body systems and performance. So aerobic training strengthens the heart and improves lung function, increasing the rate of oxygen delivery and waste product removal. It also results in capillarization, or the formation of new capillaries in the muscles, enhancing blood flow, and an increase in the number and size of mitochondria, increasing aerobic energy production. As a result, aerobic training methods, including continuous and fartlek, improve cardiovascular fitness and typically muscular endurance. Aerobic training is therefore beneficial for endurance athletes who need to work at moderate intensities for extended periods of time. Anaerobic training, including plyometrics, interval training, and weight training, typically involves short, high-intensity bursts of activity, interspersed with rest periods, rapid muscular contractions, and high force production. It improves the rate and efficiency of anaerobic respiration, as well as the body's ability to handle lactic acid, reducing muscle fatigue. It also leads to muscular hypertrophy, making the muscles larger, and improvements in strength, speed, and power. Anaerobic training is therefore beneficial for high-intensity, short-duration activities, for example sprinting, long jumping, weightlifting, spiking in volleyball, and scrummaging in rugby. Now, both aerobic and anaerobic training, if correctly implemented, will, over time, allow athletes to train for longer and more intensely, resulting in further improvements in fitness and sports performance. You need to understand the long-term effects of training on the muscular-skeletal system and explain the benefits for performance. So weight-bearing exercise, such as weight training or running, puts stress on the bones, leading to improvements in bone density and strength. This allows athletes to deal with the demands of frequent and intensive training and reduces the risk of fractures, which is particularly relevant for contact sports such as rugby and kickboxing, and those in which falls are frequent, like skiing. High-intensity weight-bearing exercise, like plyometrics or weight training, increases the strength of the ligaments, which hold the bones together at joints, and tendons, which connect and transfer force from muscles to bones. This improves joint stability and reduces the risk of tendon and ligament injuries, which are often severe and long-lasting. Several training methods, but particularly weight training, leads to muscle hypertrophy, which is an increase in size or mass. Stressing the muscles by lifting weights causes microscopic tissue damage. The body responds by increasing protein synthesis and cell size to repair the damage, leading to bigger and stronger muscles over time. This training adaptation is particularly beneficial for athletes who rely on strength, power, and mass, including sprinters, weightlifters, rugby forwards, and shot putters. Now, in order for the body to adapt to the loads imposed on it through training, athletes must allow sufficient time for rest and recovery between sessions. Only when resting can the bones, ligaments, tendons, and muscles repair themselves and become stronger. Next, you need to understand the long-term effects of training on the cardio-respiratory system and explain the benefits for performance. So aerobic training methods like continuous and fartlek increase the size and strength of the heart. This means that a trained heart can hold more blood and contract more forcefully, increasing resting stroke volume, the volume of blood pumped from the heart each beat, and maximum cardiac output, the volume of blood pumped by the heart each minute. The increase in stroke volume means the heart doesn't need to beat as often to deliver the same volume of blood. As a result, trained athletes tend to have lower resting heart rates. Aerobic training also leads to capillarization, or the formation of new capillaries in the muscles, improving blood flow and gas exchange, an increase in the elasticity of the muscular walls of arteries and veins, leading to a reduction in resting blood pressure, and an increase in the number of red blood cells, raising the oxygen carrying capacity of the blood. These adaptations serve to increase the rate at which oxygen and nutrients are transported to the muscles, lactic acid is broken down or the oxygen debt repaid, and carbon dioxide is removed. This improves aerobic energy production and fatigue resistance, allowing athletes to work at higher intensities for longer periods of time and recover faster after exercise. The long-term effects of training on the respiratory system include an increase in lung capacity or volume and vital capacity, which is the maximum amount of air you can forcibly breathe out after taking the deepest possible breath in. In other words, trained performers are able to take in more oxygen and expel more carbon dioxide with each breath during exercise. Aerobic training also increases the number of alveoli in the lungs. This provides a larger surface area for gas exchange, increasing the rate at which oxygen diffuses into the blood and carbon dioxide diffuses out. Finally, aerobic training strengthens the diaphragm and intercostal muscles. This makes breathing more efficient, freeing up energy for other activities, and increases tidal volume and vital capacity. Collectively, these adaptations increase the rate at which oxygen enters the bloodstream and carbon dioxide is removed from it. As a result, more oxygen reaches the working muscles, improving aerobic energy production, fatigue resistance, and overall cardiovascular fitness. This allows athletes to work at higher intensities for longer periods of time and recover faster after exercise. Well done, you've just covered absolutely everything you need to know on the long-term effects of exercise. If you have any questions, leave a comment down below, and I'll see you next time for the first 2 syllabus objectives in topic 3.5 on PAR-Q and injury prevention.